So guys, today we'll be doing a question on patterns and sequences, which requires, as with everything else, critical thinking, right? So number 7A from May 2019, the nth term, which is Tn of a sequence, is given by T subscript n is equal to 3n squared minus 2. This is the formula for your pattern, right? Or your sequence. So show that the first term of the sequence is 1. So I have a pattern. My first term is my answer, which is 1. Then we'll have comma, the second term, comma, third term, etc. So the first term is 1. They said to show that, right? So therefore, we start at 1, right? So 3 by 1 squared minus 2, when we solve that, we got 1. Therefore, we would have shown that the answer for the first term of the sequence is 1. Second, what is the third term of the sequence? So, okay, before we get to that, if we were to work out the second term, T2 would be equal to what?
2 in brackets
3.
Yeah, sorry, 3 in brackets 2 squared minus 2.
How much is that?
10.
10.
10. Third one. So what is the third term of the sequence? So this is the second term. The third term would be T3 is equal to 3 by 3 squared minus 2, which gave us 3 by 9, which is 27. 27 minus 2 is 25. This is the third term. We're good?
Yeah.
All right, given that Tn is equal to 145, what is Tn?
Three n squared subtract 2.
They said this is equal to,
145.
therefore, what am I writing?
145 is equal to 3n squared subtract 2.
3n squared minus 2 is equal to 145. What did they tell us to do? Find the value of?
And
Please solve the formula. Thank you. Right, so we have Tn is equal to 3n minus 2, and we're solving it. We know how to solve this. Add 2 on both sides. 3n squared is equal to 147. We divide by 3 on both sides. N squared is equal to 49. We square root both sides. N is equal to positive or negative 7, but our sequence is positive numbers, so therefore n is equal to 7. Part B, the first 8 terms of another sequence with nth term, un, are 1, 1, 2, 3, 5, 8, 13, 21, where the first term, so remember this is represented by the term, right? So they are saying the first term u1 is equal to 1. Remember the answer is the term. The second term u2 is equal to 1. The third term, well, they didn't give us the third term. They gave us the pattern for the term. So to find any term, you say u n minus 1 plus u n minus 2. Somebody tell me, what is n minus 1? We have an n. un is equal to un minus 1. What is n?
the term.
So
The
the number, what is n minus 1?
The number minus 1.
The number before it. And what is n minus 2? What is n minus 2?
That's the number minus 2.
Correct, the number, 2 numbers before it, right? So, yeah, all of these things we want to be able to understand. So, If I was to randomly say n is my number, what is the term n minus 1? What's the term n minus 1?
Miss n minus 1.
What's the term for n minus 1 if my number n is 9?
9 minus 1.
Which is?
8.
And what is the term n minus 2?
7.
All right, we see the pattern, right?
Yeah.
All right. No?
I'm a silos.
What? What, Matthew?
That's all I had.
Huh?
Miss my head is in now.
Your head hurts in here? Too much maths?
Yeah, miss.
Never. You should say there's never a
Yes,
such thing.
I understand that's what you're doing here, but what you was explaining before, I was
Right, so remember
lost.
n is a variable, right? Let's think about algebra. Everything is algebra. N is a variable, right? What's the number before n? What's the number before n? Anybody? If we're doing algebra, what's the number before n?
N subtract 1.
N subtract 1, because we don't know what n is, but we know the number directly before n is n minus 1. The same way we know 9, the number before 9 is 8, which is 9 minus 1. You're with me? Yes? No?
Yes,
Yeah, miss.
Matthew, that was a yes or no?
yes, miss.
What's the number before 8?
7.
7. What's the algebra number before n minus 1?
Negative n.
What?
N minus 2.
Oh, you get negative n. Why do we
And then
change the
0?
stuff? No, 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 no.
N minus 2.
Right, so we're continuing. Un minus 1 means one term before un. Un minus 2 means two terms before un. So when we come down, they said, for example, because they are now, warming your brain up to what they're doing. So for example, U5 is equal, the pattern is Un minus 1 plus Un minus 2. Un minus 1 is one term before Un. So one term before U5 is U4. You're with me?
Yeah.
And two terms before U5 is
2 terms before?
U5.
3.
Remember, it's one term and then two terms. You're with me?
Yeah.
Yes, miss.
Anakin?
Yeah, miss. I was here to do the 7.
Right. You want me to do this? You want to see me do this 7?
The U7.
Right, U6 and U5.
Oh,
One
it's
term
solid.
Right, so one term
Right,
before
you
U.
can try.
Okay, one term before U6 is, one term before U7 is U6. Two terms before U7 is U5. Everybody with me, right?
Yeah.
Right. What does U5 mean? The term, right?
Yeah.
So the fifth term is based on adding the two terms before it. That's what they're saying. So U4, we have to go back up here. Which one of them is U4? 1, 2, 3, 4. That's how we got 3. Where's U3? 1, 2, 3, 2. 3 plus 2 is 5. Let's do U7. Let's do U7. U7 is U6 plus U5. Where's the 6 term? 1, 2, 3, 4, 5, 6. Right? That's how we got 8. Where's U5? The term before it, 5. 8 plus 5 is 13. How you all feeling?
Good.
So remember, these are the terms are the answers in the sequence. So U4 is 1, 2, 3, 4, which is 3. U3 is 1, 2, 3, which is 2. 3 plus 2 is 5. U6 now is 1, 2, 3, 4, 5, 6, which is 8. U5 is the term before it, which is 5. 8 plus 5 is 13. So tell me, they said write down the next two terms, that is U9 and U10. What is U9? How to work out U9?
U8 plus U7.
How to work out U10?
U9 plus U8.
What is U8?
21.
21. What is U7?
13.
13. Given us?
34.
Nice. So that's U9, right? So I could put in 34. You're with me?
Yeah.
Now what is U10? What's U9? Sorry.
34.
And what's U9?
U8.
U8, sorry.
21.
Given us?
55.
I could put in 55, yes?
Yeah.
Yes, miss.
Not bad at all. Aniki? Was it what you
Yes, I
expected?
understand. I now understand it's a pattern with the numbers.
Correct. And this is exactly what the question is about, patterns and sequences. You have to pick up the patterns with the question. So part 2, which term in the sequence is the sum of U18 and U19? Which term will give you U18 plus U19?
U20.
Thank you. U20 is equal to U19 plus U18.
Yes, miss.
Yeah.
All right, all right. Show that U20 minus U19 is actually equal to U19 minus U17.
Okay.
All right, all right, all right. So, all right. So what they ask us to do is show that U20 minus U19 is equal to U19 minus U17. All we have to do is show that somehow when we work something out, it's equal to each other. So what I did is I decided to break up U20 and U19. What is U20 broken up?
U18 plus U19 plus U18.
Right, and then I put in back the minus U19, right? I didn't break that up. I didn't try that as yet. I just said, let me try to break up the first one, right? So we understand the left-hand side, right? I put this back.
Yeah.
Now break up the first one again. Sorry, this is equal.
U18 plus U17.
Minus U17, right?
Yes.
According to algebra, U19 minus U19 cancel out, right?
Yeah.
And then U17 minus U17 cancel out, right?
Yeah.
And we end up with U18 is equal to U18. Yes?
Yeah.
Therefore, we show that they are equal to each other. Geometry and trigonometry question. The diagram below shows a circle where AC is the diameter, and they told us that, right? AC is the diameter, B and D are two other points on the circle, and BCE is a straight line. Angle CAB is equal to 28, and angle DBC is equal to 46. So we identify that triangle ABC is a right angle triangle because AC is the diameter and any triangle formed on the diameter is a right angle triangle. Meaning that in this corner, how much would this be? Angle ABC will be equal to how much? 90 degrees, right? For a right angle triangle. And so yeah, that's one thing that we identified. They also told us that angle CAB, so to form an angle, you start at C, you go to A, then you go to B. So it's going to be between those two lines there. So CAB, angle CAB is going to be between the line CA and AB, sorry. So between CA and AB, so this is where the angle is on CA and AB. This is how we identify an angle, right? So it's between these two lines. So they said that's 28 degrees. So the same thing for angle DBC is going to be between DB and BC. So where's DB? DB is here and BC is here. So it's going to be between those two lines there. Not more, not less. Any questions?
Yes, could you go to all of them?
No problem. So we have to find an angle, we follow the lines. So if they say this also means an angle, so this means angle CAB. To find the angle CAB, we know that the angle is at A, but there could be many angles at A. When we look at A, there's an angle here, there's an angle here, and there's also an angle here, right? So we don't know which one they're talking about. So the first letter and the last letter will guide us as to where the angle actually is. So we start from C, right? We start from C and we go up to A. And then we take from A and we go down to B. C to A to B, and the angle is between those two lines. So it's the same thing if we do angle DBC, right? We go from D to B and B to C, and the angle will be in between those two lines there. That's why they told us one was 28 and one was 46. Are we good?
Yes.
Awesome. So, right, we know how to identify where our angles are. We know how to find a right angle triangle if there is any in circle geometry. We look for the triangle that is formed from the diameter. How do we know that a line is a diameter? This here, the center is identified. So you see how they put that dot there? That is to tell you that AC is not just a random line, but it is the diameter, because remember, a diameter passes through the center of a circle. So this is for them to tell you, hey, AC is the diameter, right? And any lines forming from the diameter creating a triangle is a right angle triangle. So tell me what other triangle is a right angle triangle. So we know ABC is one. What other triangle?
ACD.
A.
CD.
Correct. ACD is also ACD or ADC. We could interchange the letters. That's also a right angle triangle. Any questions? Anyone? All right, so let's go and see what they're going to ask us to do. So calculate the value of each of the following angles. Show detailed working when necessary and give a reason to support your answer. So we're just going to clear it out and see what so they want angle DBA. So we start at B, we go to B, and then we go to A. So this is the angle inside of here. All right, so based on what we know about D, so this is the angle we want. What do we know about this part? So this angle is actually inside this triangle here, right? Yeah?
Yes, miss.
So what do we know about that triangle? It is
Right angle.
it's a right angle triangle, and we know that where the two straight lines meet in the right angle triangle form how much degrees?
90.
90. So we know that this corner is 90 degrees because a right angle triangle has a straight line and two lines meeting, right? So where the perpendicular line meets the straight line on the ground, it forms a 90 degrees. So if I know part is 46, how do I work out the other part?
90 minus 46.
Correct. So angle DBA is equal to angle ABC minus angle, what angle is the 46? DBC, right? Yeah. We know angle ABC is 90 degrees, so that's just 90 degrees minus 46 degrees, giving us how much?
44 degrees.
44 degrees. Right? If they want any other information, you just say angle, sorry, we just say, yeah, angle ABC is 90 degrees since triangle ABC is and of course you're right, it's a right angle triangle. So once they see that you know that it's a right angle triangle and you know that that would be 90 degrees, so you subtract it, that is your detailed working and your reason supporting your answer.
This is that you identify a right angle triangle by a straight line and two lines coming out from it, isn't it?
The diameter line.
No, but how do you identify a right angle triangle itself without being visible?
A triangle formed on the diameter line. Yes? So AC is a diameter line. AC is a diameter line. And we had two triangles formed from that line. Therefore, we
I understand that one. I'm saying if this circle wasn't there.
if they,
Oh, this circle wasn't there.
the circle will be there, it's circle geometry. Yeah? Am I answering a question? So we're going on to the next question. Angle DAC. Right, we start at D. We go to A. Then we come down to C, so it's inside here. So again, we are back in another right angle triangle, right? If we close this off, we see that we are inside this triangle. So what do we know about the angles in this triangle so far? In which corner would be our 90 degrees?
D.
In the corner of D, nice. So this will be 90 degrees. What else do we know? Do we know the size of anything else? We know that here is 44. Right? Do we know anything down here? So how many degrees are there in a triangle?
Miss 180.
Nice. So a triangle has 180 degrees. So what we need to do is, if we have to find missing degrees, we need to be finding out all the parts that could add up, and we could subtract to find what's missing from 180. So if I have this here, I know that on top is 28, I know that here is 44, and I know here is 46. Can I find here? Let me change this color. Can I find the size of this angle here? Angle ACB or BCA, anyone? Who can tell me what is the size of angle ACB?
Add up the 20, 46, and 44, and minus it from 180.
Correct. So that will be 28 plus 44 plus 46 minus from 180, giving me 28. Right, so we found 28, we found 44, we found 46, we found 62. Now we are trying to find here, we are trying to find up here, and we already know here is 90. So we found 90 degrees. So what we're trying to find now is this angle up here. So there's a rule, they have many rules in circle geometry. So there's a rule that says any angles formed at the circumference from the same chord are equal to each other. So we remember what is chord, what is a chord, because we would have done that, right? A chord is a line that goes from circumference to circumference, but it does not pass through the center of the circle. So the difference with AC and DC is that DC is a chord, but AC is a diameter, because AC is actually passing through the center of the circle. So let's identify some chords. I said DC was a chord. What's another chord from the diagram?
AD.
Is that a chord, isn't it?
AD. What's that, Joshua?
Just said the chord was again.
Going from circumference to circumference without passing through the center of the circle, you should have those notes already, because we did that when we were doing measurements. So from circumference to circumference without passing through the center of the circle. So AD is another chord. What's another chord? Kyla and Joshua, what's another chord quickly, please?
Miss BC.
BC is a chord. Joshua, what's another chord?
BD.
BD is a chord. One more chord missing, I believe so.
AB.
Nice. Right, so these are some chords, right? Remember, The chords are the line going from circumference to circumference without going through the center of the circle. The space between the chord and the circumference of the circle is called what? Yeah, we're doing a revision. What are these spaces called? Starts with S.
Sectors.
Nope. But a sector is formed connecting from the center of the circle going outwards. So a sector is formed by radius, by two radius. So it's segments. So the space between a chord and the circumference is the segment. Right, the sector is created between two radii. So if I do this, this will be a sector. Yeah? Tell me if you'll follow me. No?
Repeat, please.
So just go back and review it, right? You'll have to go back and review it. A sector would be coming from here to here. This will be a sector. Because this is a radius and this is a radius, and we're going to the center of the circle. This black space here will be a sector. So it's between two radii. Yeah, that's a sector there. So go back and watch your images and the questions we would have done before to review on what are sectors and all these different things. Right, so the rule that we are focusing on now is any angles formed at the circumference from the same chord are equal to each other. So we have this chord here, BC. The angle created on the chord are the opposite circumference. So inside here, an angle was created. And another angle was created on the same chord here. So these two angles that were created at the circumference from the same chord are equal to each other. Therefore, angle DAC will be equal to how much? So common chords, the AC is equal to 46 degrees. Let's run it again. Two lines formed at the circumference from the chord DC. Two lines formed at the circumference from the line DC. Therefore, the two angles at the circumference will be equal to each other. Therefore, here will be 46 degrees. So we know here is 90 degrees. We know here is 44 degrees. How much would inside here be? This line here, how much would here be?
44.
Correct, 44, because 2 are the circumference from the same chord. Yeah, although we didn't need to know that one, right? So let's see what else we have. This is, how much is this? 46. Let's see what they want. BCE. BCE. So outside here now. B to C, C to E. Outside. So, Grayson. They want here. Everybody understand why they want here, right? Why it's there? B to C, C to E. Inside of here is 90 degrees. We know that here is, we know that here is 44, right? So far, we're just putting in what the question, what we know from the question itself. So up here is 46, at the bottom is 90, across there is 44. Now, there's something called a straight line degrees, right? So straight line degrees equate to, anybody knows how much degrees is on a straight line? $180 degrees. So once you have a straight line, a semicircle is formed, and this is 180 degrees. Why? Because if you form a next 180 degrees, you'll get your full circle, which is 360 degrees. Yeah. So anytime you see a straight line, we know that it's 180 degrees. Therefore, we know that this is a straight line here. Therefore, this entire part here equates to 180 degrees. In order for us to find the part in green, we need to know about the part in red, in yellow. Everybody's with me? All right. So in order for us to find the part in green, we need to find the part in yellow. In order for us to find the part in yellow, we activate another rule or apply another rule, right? A rule that talks about a cyclic quadrilateral. So we know a quadrilateral is a shape that has 4 sides, right? Quad. So anytime you have a quadrilateral in a circle, it becomes a cyclic quadrilateral when all 4 points touch the circumference of the circle. So we see in this shape here, this shape here is a quadrilateral. 1, 2, 3, 4. But it now becomes a cyclic quadrilateral when the 4 corners of the quadrilateral is on the circumference. So I could have a circle looking like this, and I have a center, and I have a quadrilateral looking like this. Is this a cyclic quadrilateral?
No.
No, it isn't, but it is a quadrilateral. But it's not a cyclic because this stopped in the middle. If it had went all the way up, now this here is a cyclic quadrilateral. Everybody with me? So the 4 points or the 4 corners of the, or we could say the vertex, corners of the quadrilateral touches the circumference. That makes it a cyclic quadrilateral. And the rule for a cyclic quadrilateral is that opposite angles sum to 180 degrees. So we're watching two things. We have a straight line, which is this. But in order for us to find out the green part of the straight line, we need to find the yellow part of the straight line. And the yellow part of the straight line is inside a cyclic quadrilateral. And we know the rule of a cyclic quadrilateral is that opposite angles sum to 180 degrees. Tell me the colors that are opposite to each other. I'm going to put red in this corner, and well, I'm going to leave at the bottom as yellow, right? And then I'm going to put pink in this corner, and then I'm going to put green in this corner. So what two colors are opposite each other?
Pink and green.
Pink and green, correct. Therefore, when you add both of them, you should get 180 degrees. Yeah? When you add up this entire corner with this entire corner, you get 180 degrees. Let's try it. 44 plus 46 plus 90 is 180 degrees. And therefore, when you add up the red and the yellow, you should get how much? 180 degrees. So anybody who works it out first, tell me how much will be the part in yellow?
Yes, but the part in red is 74 total.
Okay. So what would be the part in yellow?
But when you add up the both, you're just supposed to get 180.
Correct. When you add up what?
The both opposite sides, opposite angles.
Uh-huh.
I'm just supposed to get a total of 180.
Yes, correct. So what would be the part in yellow?
74.
The part in yellow? I told the part in red was 74. How much would it be the part in yellow if the part in red is 74?
Miss 106.
Correct, 100.
Yes, miss. 106.
Thank you, because we have to subtract the part that we have from 180, so we get 106. Nice. So the rules of a cyclic quadrilateral is first be able to identify if it's cyclic or not. Sometimes people mix it up. Once the four corners of your shape is on the circumference, it becomes a cyclic quadrilateral. And then the rule for that is that opposite angles sum to 180 degrees. Right, so we found 106, therefore we can now find the part in green, which will be how much?
180 minus 106.
Correct, which is?
74.
74 degrees. So what we realize is that there's a 74 here, and this is a 74 as well. This is also a rule that tells us the exterior angle is equal to the interior opposite angle. So this is an exterior angle outside of your shape. the exterior angle is equal to the interior opposite, which is up here in this particular case. If I had an exterior angle here, it would have been equal to the angle up in this corner here. As we can see, if I put a straight line here, how much is this? And we're seeing two straight lines meeting. Anytime two straight lines meet, what is the angle in between them? Two straight lines. Huh?
Miss, can you repeat, please?
The angle between two straight lines is how much?
90.
Correct. So we see that this is 90 degrees. And we know that the exterior is equal to the interior. And this was also equal to 90.
Yes, yes.
Yeah. So back to the question itself. We could have just said, because up here is 74 degrees in total, outside here is 74 degrees in total. But we could have also used the cyclic quadrilateral rule to find the inside of here by subtracting 74 from 180, giving you 106 degrees. And then subtracting the 106 from 180 again because of the semicircle straight line, giving you 74 degrees. A lot of concepts. I hope you all, took notes of each of them. Right, so EG, we're moving on to this, trying another geometry question. EG is the diameter. We know that because we have a diameter and we have triangles forming from the diameter, we know that they are right angle triangle. So what's the first right angle triangle we can identify? So EFG and ECG form the right angle triangles, right? Then we have
This is the definition for tangent. Yes.
so a line. So AEB is a tangent line. So this AEB is a tangent line. A tangent line is a line that touches your circle at one point. Or touches your circumference at one point. So it only touches at E. That's the only part this tangent line is touching. Right? CF, what is CF? So we identified the two parallel lines, which is CD and AB, CB and AB, and they are cut by a transversal line, which is the diagonal line. We see a shape forming like a Z, and the interior angles are equal to each other in that particular shape. So because at the bottom was 68, on top will also be 68. And that's our answer for E, C, D. Now they want angle C, E, G. So if we follow the lines, we'll end up with it being right here. C to E, E to G. How do we figure out how much is in here? Anybody could watch this and tell me what they're picking up about this area here? Remember, there's a rule I told you all about, well, what you know about two straight lines meeting each other, what type of angle is formed there? A 90-degree angle. So we know 90 degrees is formed on this side and 90 degrees is on this side. So please find
90 minus 68.
correct. So that's 22 degrees. Because this is a 90-degree angle here. And it will be a 90-degree on the other side as well. So a 90-degree angle was formed from EAEG. Therefore, the missing part of the 90-degree will be 90 subtract 68, giving you 22 degrees. All right, so now they want C, G to F. So that's going to be inside here. Again, what observations do we know from this side, this big angle here? What rule we think we're going to have to apply now? So let's start and run this again. The first thing we did was worked out this part. We got this to be 68 because we have two parallel lines being cut by a transversal line and the two interior angles are equal to each other. Therefore, if down here is 68, up here is 68. Everybody got that, right?
Yes.
So we had the 68 here.
Can you repeat that one, please?
Two parallel lines cut by a diagonal line. It forms like a Z shape. Right? So if you look good, you'll see a Z forming here. And the inside of these, the two inside parts of these Z's are equal to each other. So this is, if this is 20, down here is 20 as well. Yeah. So we see the Z here. And the interior parts are equal to each other. That's how we say, because the bottom is 68, the top is 68. Yeah?
Okay.
You'll have to catch up on your recording. Then we go with 68 here. Then we say that what they ask us for, then they ask us for here, right? Somebody tell me how we worked out this part, this inside part here.
90 minus 68.
We know that a 90-degree angle was formed because anytime you have two straight lines meeting each other, it's 90 and 90. Or if it was a straight line alone, it would have been the whole 180. Yeah, so we see here that the two straight lines are meeting each other, therefore forming 90 degrees on both sides. Now, if we know that 90 degrees is forming on both sides, or on one side, the side that we are focused on, then this part here, if this part here is 68, then the difference will be 90 minus 68, giving us 22. We on board? Yes, any questions? All right, so now that we have the 22 and the 68, the other thing they ask us for is up here. Now, we go on to another rule that talks about cyclic quadrilaterals, and opposite angles in cyclic quadrilaterals are equal to each other. So we know that it's a cyclic quadrilateral because all 4 points touch the circumference of the circle. So anytime you have 4 lines making a shape and all 4 points touch the circumference of a circle, it's called a cyclic quadrilateral, right? And in a cyclic quadrilateral, opposite angles are equal to each other. So therefore, these two are opposite and these two are opposite. And what do we know about the opposite angles? Opposite angles in the cyclic sum to 180 degrees. So that means the 2 parts in red, when you add them up, you should get 180 degrees. And the 2 parts in green, when you add them up, you should get 180 degrees. So using all of that, right, we're going to now find out how much our CGF is up here, right? So we know here is 22, right? In order for me to know what here is, I need to know what here is, the full thing, right? Because I know that when I add these 2 parts in blue, they must give me 180. And if I have to find here, it will be easier for me to find what down here is and just subtract it from 180 to get what on top is, right? Everybody following what I'm saying? Any questions?
Yeah, miss.
Right, so, but we have a little sticky situation because we don't know what this part is, so we have to now go and find that part. Now we know what 68 is. If I say, well, I go up here now and I try to find what up here is, because I could say, well, I could say this whole thing is a triangle here, inside here, forgetting the cyclic. I could say, well, this here is a triangle and I know a triangle is 180 degrees. So if I find here, if I find this part here, which is just 74, we know that this is 74 because angles on a semicircle form 180 degrees. And if the outside is 106, then the other part will be 74, right? So we say that was easy. We just know that this is 74 degrees inside here. And for me to find the missing part, I could say 68, add 74, add 22, and I subtract all of that from 180 because remember, it's a full triangle inside of here, so I could get this missing part. When I did all of that, I got 16. So again, the part in pink is a full triangle. We know a triangle has 180 degrees. So if I find the missing parts, which was very easy for me to find the 74 because remember, this is a straight line. Just like down here would be 180 degrees. The full semicircle would be 180 degrees. Anytime I have a straight line, just like the same way, if I have 2 straight lines meeting, one will be 90, one will be 90. If I have the straight line, the whole thing will be 180. This is just a straight line upside down, right? If we see it, it's right here, right? 180 degrees. So inside of here would be 74. Right, and inside here was 68. So I could say 74, 74, add 68, I knew down here was 22. And when I subtract all of that from 180 from the full triangle, I get the remaining part of the triangle, which is 16. So now we did all of that and we got our 16. We know the full part, we know the full angle for below, which is just 22 plus 16. So at the bottom here is actually just 38. And again, we go back up to the rules of the cyclic quadrilateral, opposite angles sum to 180. So remember when we had the red lines here, and here must add to give me 180. So therefore, if the bottom is 38, the top will be 180 minus 38, which is 142 degrees. So that's the question from top to bottom, basically. We got the 68, we got the 22, we got the 142. These are the three things that they asked us to work out. Let's see if they ask us anything else. That was all. So tell me, if I was to ask you to work out other stuff, if I asked you to work out hair, yeah, what's that?
So when we was looking at the bottom, we were looking at in piece. One was 22, the other one was 16. How come we work out G now, the other G, as one whole angle, rather
Because
than in parts?
they asked you for CGF, which is here. The question asked you to work out angle CGF. And we know to find an angle, we follow the line C to G. C to G, G to F. Between those two lines is our angle. Yeah?
Yes.
So if the question asks you, right, so if the question asks you, what is angle CEF, where would that be? C to E, C to E, E to F, which would be this entire thing, right? And we know that that would have been how much? 38. From the 22 and the 16. Yeah?
Yes.
All right, if the question asks you to work out angle F, E, B, how much would that be? 7. F to E, E to B, how much would inside here be?
74.
Good job, right? Parallel lines cut by a transversal line, interior angles will be equal to each other. So your 74 would be equal to your 74. That was quick and that was good. Yeah. What about if they ask you to work out C? So you said this was 74 degrees. What about if they ask you to work out angle C? Sorry, angle G? G, C, E. G, C, E. Any ideas?
Before answer, GCE. That's triangle as well, right? And GE is 90 degrees.
GE is not 90 degrees.
No, I mean, C, the CF line.
The
G,
yeah.
cutting that line would be 90 degrees on either side. On top and on the bottom. Right?
Top and bottom, what you mean?
And the next side.
Here?
No, the same side but opposite.
Here?
Opposite the line. No. Right with the, yeah. So if the angle EFG
You wouldn't even believe how easy it is. The answer is actually highlighted. What is this? And what is this? The exterior angle is equal to the interior opposite. So it will just be 74 degrees. Yeah. The exterior angle is equal to the interior opposite. So within your cyclic quadrilateral, this is the interior opposite of the 74, that is the exterior. So that's just 74 degrees.
So I told the exterior, but outside the signal. It's not outside the signal, outside the angle.
It's like outside the shape. So the exterior angle started here. Yeah? It was this.
Okay.
So it was outside the BC line. And
So
it
it could
was
still be within the signal, but outside the
outside
shape
the
itself. Okay.
Yeah. So the exterior angle, you see it stop at this line here. And it's equal to the interior opposite. So how much was here? 22. And how much was here? When we add up all, what are we supposed to get when we add up all these four parts?
180.
180 degrees, which we do get when we add it up. So that tells us that we are correct. Yeah. All right, and how else do we know if we're correct again? How much would here be? And how much would here be? So we know here is 142. We know here is 38. How much would that missing part be? How much would this part be? The entire part here.
68.
Here?
Never mind.
How much? I want to hear Tiffany. I want to hear Kyla. How much would that red part there be? Huh? Right, so 74 is opposite 106 in the cyclic quadrilateral. Therefore, when we subtract them, the difference will be 106, and that's the answer there.
As I said, the angle outside is equal to the opposite interior angle.
Yes.
So
The
for
exterior angle.
so for AEC, it is 68.
AEC, yeah.
68 degrees. DEB or just DE. Oh, sorry. FE. That would be 68 as well. Or we have to
FE. So wait, what are you talking about this line here? This exterior angle goes on to here. Right, we got this as 74. That whole thing was 74, and this whole thing was 74. This interior angle, we got this as 74. I'm not really seeing an interior opposite based on this, like if I'm being very honest. So look at the shape properly, right? The shape is tilted as well. It has a tilt. So look at how it is shaped. This, you're actually seeing that this is the interior opposite. With this, are you actually seeing that this is the interior opposite? Are you? Tell I. Tell me. For you.
And so I want to know is how come you outline one angle,
Because that would.
but on the inside you outline two angles, because the line D split the angle in half.
The line D split the angle in half. The line.
Or it split the angle, not in half, but it split the angle.
Line D split what angle? Here?
Line CD. Yeah.
Because we're watching, this is the shape that we're watching, right? The cyclic quadrilateral. This is the shape that we're watching. So we're going to have a lot of different lines that are going to be cutting left, right, and center. We have a triangle here. We have a triangle here. We have a cyclic quadrilateral here. We have a triangle here, right? With a bunch of different rules. So in one question, you might have to split the angle to get what you're looking for. In another question, you might have to use the two angles to get what you're looking for. You understand what I'm saying? So sometimes you might say, well, this with this. Well, this is obviously with this, because this is where the rule is. The parallel lines cut in by a transversal line. Right? We know that this was 22. We know that this was 16. Just from watching 68 plus 22 plus 16, we can subtract that from 180, and we know that outside of here is 74 regardless. Right? Just from knowing that this was 90, so I just going around the circle, right? 90 plus 22 minus 180. If I say 90 plus 22 minus 180, I'll get the missing part of this triangle, which was already 68, which we already knew was 68, right? 74 is not equal to 68. So this is definitely not the interior angle that are equal to each other. So we know that the 74 will actually be equal to this entire interior angle, because whatever this missing part is, it will sum up to give you that missing part for the 78. I hope you're following me.
Yeah.
So we already know that this was 68 here. We already know that when we work out the 22 here and the 16 here, and to find the difference, we can say 68 plus 22 plus 16 minus 108, we got 74. We see that 74 is not equal to 78. So this is the interior angle, which is the whole thing is 74 degrees. See me? We know that this part here is 74, not just because of the 106 minus 180, but also because of the z as well, where the 74 is equal to 74. Right? So it has so many ways that we could just be flipping this and finding the answers using different methods. Now, I already know that this is an exterior angle, but it is definitely not equal to this interior angle, because I know that here is 74. And it definitely cannot be equal to something bigger if the smaller part is 74. Following me?
Yes.
Right. So I like that you're asking questions, and I like that you're trying to put things together to fully understand. You know, that is always welcome. Right? So we here and we learned a bunch of different rules for geometry, and I know that you'll have a bunch of revision to do, because it does not even stop here, right? So what y'all could do is we will definitely try about 2 more questions on these and put together the rules. And then we will go on to doing the trigonometry part of the questions. I know that we would have started some of this already, and we did cosine and sine, cosine rule already. I know to myself we did cosine rule and sine rule. Yes? So that's what we will be doing, revising in these coming questions.